A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
Herman, I was looking at our Home Assistant dashboard the other day, and I had this sudden, sinking realization. I have spent more time over the last 3 years troubleshooting why the kitchen lights don't turn on when I walk in than I have actually spent enjoying the convenience of those lights. It is that classic smart home trap we always talk about. You spend 5 hours of your weekend wrestling with indentation in a YAML file, staring at white space and colons, just to save 3 seconds of effort on a Tuesday morning. It is a bad trade, Herman. It is a mathematically objectively bad trade.
Herman Poppleberry here, and Qwen, you are hitting on the literal definition of YAML fatigue. We have all been there. It is that specific point where the hobby starts to feel like a second job, where the boss is a finicky configuration parser that hates you and refuses to give you a raise. But I think that is why the prompt our housemate Daniel sent us this week is so perfectly timed. Daniel was asking about how we move past this slog. He wanted us to look at how Home Assistant is evolving from this rigid, logic-based system, where you have to anticipate every single variable, into something much more fluid and, frankly, much more intelligent.
It is a great question because we are right at the inflection point. For a long time, a smart home was really just a collection of remote controls and some basic if-this-then-that scripts. You were the brain, the house was just the muscle. But Daniel is pushing us to look at the agentic brain. This idea that the house doesn't just follow a script like a player piano, but actually understands intent. We are moving from manual programming to true home management. We are talking about a system that doesn't just wait for a trigger, but understands the context of your life.
That is the core of it. And the big news that really changes the game here, the thing that makes this conversation possible today in March of 2026, is how Home Assistant has integrated the Model Context Protocol, or MCP. If you have been following the news from the January 2026 release, you know that the developers have basically baked in the plumbing needed for local AI agents to actually talk to your hardware in a standardized way. It is the end of the era where every single integration needed a custom-coded bridge to a large language model. We have moved from bespoke, handcrafted bridges to a universal transit system.
So, today we are going to dive deep into that. We are talking about how Agentic AI and MCP are killing the tedium of the smart home. We will look at the technical side, like which local models you can actually run in a basement or a closet without a massive power bill, and we will talk about the imaginative side. How does a house maintain itself? How does it suggest its own improvements? How does it stop being a project and start being a partner?
I am really excited about this one because it feels like the payoff for all the years we have spent building these systems. If you have been listening to us for a while, you know we have talked about the fragility of these systems in the past, specifically in episode 762, where we discussed the decoupled brain. But now we are finally seeing the fix. This is not just about making things easier, it is about making them actually smart. It is about moving from a house that is connected to a house that is aware.
Well, let's start with the brain itself. Because when we talk about an agent, we are not just talking about a chat box where you turn on the lights and it says OK. We are talking about something that can take an action, reason through a problem, and perhaps most importantly, observe. Herman, for the people who are still thinking in terms of voice assistants like Alexa or Siri, how is an agentic brain in Home Assistant fundamentally different from what they have in their kitchen right now?
That is the crucial distinction, Qwen. A traditional voice assistant is basically a glorified keyword matcher. It is a giant switchboard. You say a specific phrase, the cloud matches that phrase to a single command, and it executes it. If you deviate from the script, if you say it is a bit dark in here, instead of turn on the living room lamp, it often breaks or gives you a web search result for the word dark. An agentic brain, specifically one powered by a large language model using MCP, understands the state of your entire home as a context window. It doesn't just see a light switch, it sees the energy usage, the time of day, the historical patterns, the weather outside, and the specific goals you have set for your evening. It is the difference between a remote control and a butler.
And the MCP part is the bridge, right? Because the model needs to know what it is allowed to do. It needs a map of the house.
Right. Think of the Model Context Protocol as a universal translator for tools. In the old way, if you wanted an AI to turn on a light, you had to write a specific function, a piece of Python code that the AI could call. You had to tell the AI exactly what the light was called and what parameters it accepted. With MCP, Home Assistant can basically hand a menu to the AI and say, here are all the entities in this house, here are the services they support, and here is the standardized way you format a request to use them. It decouples the intelligence from the hardware. The LLM doesn't need to know how a specific Zigbee bulb or a Wi-Fi plug works. It just needs to know that the bulb is a tool it can use to satisfy your intent. It is a standardized handshake between the brain and the body.
That is a massive shift in the architecture. It makes the house feel less like a machine and more like an operating system for agents. But let's get into the technical weeds here, because I know our listeners care about privacy. We live in Jerusalem. We care about our data staying in our house. We are not interested in sending every single movement in our home, every conversation, every sensor trip to a server in Silicon Valley. So, if we are running this locally, what are we actually looking at in terms of hardware and models? Can a local box really handle the thinking required for a whole house?
This is where it gets really impressive. As of early 2026, the landscape for local inference has exploded. We are no longer in the dark ages of waiting 30 seconds for a response. If you are looking for the sweet spot between performance and resource usage, the two big players right now are Llama 3.2, specifically the 3 billion parameter version, and Qwen 2.5, specifically the 7 billion parameter model.
Can a 3 billion parameter model really handle a complex home? That seems small compared to the massive models like GPT-4 or Claude that we see online. Is it smart enough to not accidentally lock me out of the house?
It is smaller in terms of general knowledge, but for home automation, you don't need a model that can write a thesis on 17th century poetry or explain quantum chromodynamics. You need a model that is world-class at tool use and function calling. The 3 billion parameter, Llama 3.2, has been specifically fine-tuned for these types of agentic tasks. It is lean, it is fast, and when you pair it with something like an NPU, a neural processing unit, the latency is incredible. We are seeing response times drop by 40% compared to running it on a standard CPU. In a home environment, speed is the only metric that matters for user experience.
I remember we mentioned the Hilo 8 NPU in a previous episode. Is that still the gold standard for this kind of local setup, or has the hardware moved on?
It is definitely the leader for the prosumer market. If you have a dedicated box running Home Assistant, like a small form factor PC or even a high-end Raspberry Pi 5 with an M2 expansion, adding a Hilo 8 card changes everything. It offloads the heavy math of the neural network from the main processor. This means your home doesn't lag just because the AI is trying to figure out if it should dim the lights. You get that instant on feeling. We are talking sub-second inference times for most home control tasks. That is the threshold where the technology becomes invisible.
That latency issue is so important. If I say I am going to watch a movie and it takes 10 seconds for the AI to process the request, look up the entities, and start closing the blinds, the magic is gone. I might as well have just walked over and closed them myself. It has to feel instantaneous. But there is another side to this, Herman. Hallucinations. If I have an agentic brain running my house, and it gets a little too creative, could it start doing things that are actually dangerous? Like turning on the oven because it thinks I am hungry, or unlocking the front door at 3 in the morning because it misread a motion sensor?
That is the number one fear, and it is a valid one. We have all seen AI make things up. This is why the implementation of MCP and Home Assistant is so clever. It isn't just a wide open gate. You can define specific guardrails. You can tell the system that the AI agent has permission to control lights and media, but it requires a manual confirmation for security-related tasks like locks, garage doors, or high-wattage appliances. You are essentially setting the scope of the agent's authority.
So it is a permission-based hierarchy. The agent is a delegate, not a king. It has a limited power of attorney.
Precisely. And you can also use what we call system prompts to enforce safety constraints. You tell the model, you are a home assistant agent. You must never increase the thermostat above 75 degrees. You must never turn on the sprinkler system if the outdoor temperature is below freezing. These constraints are part of the context window that the model checks before it takes any action. It is a layer of logical validation that happens before the command is sent to the hardware. It is like having a very smart, very fast supervisor checking the agent's work in real time.
That makes sense. It is basically the digital equivalent of telling a house sitter, you can eat anything in the fridge, but don't touch the thermostat and don't let the dog out after dark. But let's talk about the context window itself. My home has hundreds of entities. Sensors, lights, switches, media players, energy monitors, even the battery level on my toothbrush. If I feed all of that into an LLM every time I ask a question, doesn't that get expensive in terms of processing power? Even locally, that is a lot of data to crunch.
It does if you are lazy about it. If you dump the entire state of a 500 entity house into a prompt, you are going to have a bad time. But the modern agentic approach uses something called dynamic context injection. Instead of sending the state of every single light bulb in the house, the MCP integration identifies which entities are relevant to the current request. If you are asking about the living room, the system prunes the data. It doesn't need to send the state of the bedroom window sensors or the basement humidity levels. It prunes the data down to just what is necessary for the task at hand. This keeps the token count low, the speed high, and the accuracy much better because the model isn't getting distracted by irrelevant noise.
I love that. It is like the AI is focusing its attention rather than just staring at a wall of data. Now, let's move into the imaginative territory Daniel mentioned. IDing new automations. This is where I think most people get stuck. We have all these sensors, motion, light, temperature, vibration, but we only use about 10% of their potential because thinking of the logic is hard. It is exhausting to think through every if and else. How can an agent help me actually use the hardware I already bought?
This is my favorite part of the new paradigm. Imagine an agent that looks at your historical data, not just the current state, but the patterns over the last month. It sees that every Tuesday at 6 p.m. you walk into the kitchen, turn on the overhead light, start the kettle, and play a specific news podcast. In the old days, you would have to manually build that automation, set the triggers, and hope you didn't miss a step. Now, the agent can come to you via a notification or a brief voice summary and say, "Hey, I noticed a pattern. Would you like me to create a routine called Tuesday Evening News that handles this for you? I can even preheat the kettle if I see you are 5 minutes away from home."
It becomes a consultant for your lifestyle. It is looking for the friction in your day that you have just accepted as normal.
Precisely. It can even suggest optimizations you wouldn't think of because you don't have the eyes of the house. For example, it might notice that your HVAC is working extra hard between 2 and 4 p.m. because of sun exposure on the south side of the house. It could suggest, "Hey, if I close the smart blinds in the living room during those hours, I can reduce your cooling cost by 15% and keep the room at your preferred temperature without the AC running at full blast. Do you want me to do that?" That is a level of insight that most users simply don't have the time to calculate.
See, that is where the value is. It is moving from a system that waits for a command to a system that is proactive. But that brings up the maintenance side of things. Home Assistant is famous for being a bit of a house of cards sometimes. A Zigbee node goes offline because someone plugged in a new microwave, a database gets too large and slows down the interface, or an integration breaks after an update. Can an agent help with the plumbing? Can it be the digital janitor?
Without a doubt. This is the self-healing home concept. We touched on this in episode 7062 when we talked about the decoupled brain, but Agentic AI takes it to the next level. An agent can monitor the logs in real time. If it sees a Zigbee device is dropping off the network repeatedly, it doesn't just show you a cryptic error code in a log file you never check. It can run a diagnostic. It can check the signal strength of nearby nodes, suggest moving a repeater, or even try to reinitialize the connection itself. It can tell you, the kitchen motion sensor is offline because the battery is at 5%. I have added batteries to your shopping list.
That would save me so many trips to the basement. I can't tell you how many times I have had to power cycle a hub just because of a minor interference issue that I didn't catch for 3 days. If the AI can handle the routine maintenance, the smart home starts to feel less like a project and more like a utility, like water or electricity. You just expect it to work.
And think about performance optimization. One of the biggest killers of Home Assistant performance is the recorder database. People log every single tiny state change of every sensor, every time the temperature changes by 0.1 degree, and eventually the database swells to gigabytes and the whole system slows down. An agentic AI could look at your logging patterns and say, you are logging the temperature of the CPU every 10 seconds, but you never actually look at that data and no automations use it. Can I change that to log only every 5 minutes to save disk space and improve system responsiveness?
It is basically a system administrator that lives in the box. I think that is what a lot of people are missing. They focus on the lights and the music, the fun stuff, but the health of the system is what determines if you are going to keep using it a year from now. If it is a constant headache, you will eventually just give up and go back to dumb switches. The AI is the retention officer for the smart home.
I think that is a very conservative way to look at it in a good way. It is about reliability and sovereignty. You want a system that works, that you own, and that doesn't require constant intervention. By offloading the technical debt to an AI agent, you are actually making the system more robust, not less. You are using the AI to manage the complexity that humans are naturally bad at tracking over long periods.
Let's talk about the sub-agent architecture for a minute. We did a whole episode on this, episode 795, where we talked about delegating tasks to smaller models. How does that look in a Home Assistant context? Do I have one big God agent that knows everything, or do I have a bunch of little specialized ones?
The trend is definitely moving toward the modular approach. You might have a master agent that handles the natural language interface, the one you actually talk to, but then it delegates tasks. If you ask about your energy usage, it hands that off to a specialized sub-agent that has been fine-tuned on data analysis and your specific energy provider's rates. If you are asking about security, it hands it to a sub-agent that is optimized for vision processing and sensor monitoring. This is exactly what we discussed in episode 795, but now it is happening locally on your own hardware.
Why is that better than just one big model that knows everything? Is it just about the memory?
Efficiency and accuracy. A smaller specialized model is often much better at its specific task than a general purpose model is at everything. It is also faster to load and requires less memory. In a local environment, memory is your most precious resource. If you can run 3 small models for the price of one big one and get better results, that is a huge win. Plus, it is more secure. Your energy subagent doesn't need access to your security camera feeds or your door locks. You can wall them off from each other. It is the principle of least privilege applied to AAI.
That makes a lot of sense from a security standpoint. Now, Herman, I want to pivot to the practical side for our listeners who are hearing this and thinking, okay, I am sold. I want this. I am tired of my YAML files. I want the agentic brain. What are the immediate steps? If someone is running a standard Home Assistant green or a yellow or maybe a dedicated PC, how do they actually start?
The first step is to get your local inference engine running. Most people are using Llama right now because it is so easy to set up. You can run Llama on a separate machine if your Home Assistant box isn't powerful enough. Maybe an old gaming PC or a Mac Mini. Once you have Llama running, you download a model like Llama 3.2 or Qwen 2.5. Then you go into Home Assistant and add the Llama integration.
And that is where the MCP comes in. That is the part that connects the brain to the switches.
Not quite yet. The Llama integration gives you the model, but to make it agentic, you need to use the conversation integration in Home Assistant. You set the conversation agent to use your local model. From there, you can start exposing your entities to that agent. This is a crucial step. You don't want to expose everything at once. Start with your lights and your media players. Give the agent a small playground to start with so you can see how it handles the logic before you give it the keys to the whole kingdom.
And what about the prompt engineering? I know that sounds like a buzzword, but it is really just about giving the AI its job description, right? How do you write a good system prompt for a house?
You've got it. You want to go into the system prompt settings and be very specific. Don't just say, you are a house. Tell it, you are the Poppleberry house manager. You are helpful, concise, and you always prioritize energy efficiency. You have access to the kitchen and living room lights. If someone asks to set a mood, you should dim the lights to 20% and turn on the warm white setting. Do not ask for clarification unless the request is ambiguous.
I have found that being specific about the personality really helps. If you tell it to be a professional butler, it tends to be more precise with its actions. If you leave it blank, it can get a bit wordy, it might try to tell you a joke, and it takes longer to respond because it is generating unnecessary tokens.
That is a pro tip, Corn. Conciseness is key for local models. You want them to give you the answer or take the action as quickly as possible. Every extra word it says is a few more milliseconds of latency. Another practical step is to use the Home Assistant trace engine. Most people use traces to debug their manual automations, but you can also use them to see exactly what the AI agent is thinking. If it takes an action you didn't expect, you can look at the trace and see the exact tool call it made and the logic it used to get there. It is like an audit log for your agent's brain.
That is how you build trust with the system. You don't just let it run wild, you audit it. It is like training a new employee. You watch them closely for the first week, you check their work, and once they prove they know the ropes and understand your preferences, you give them more autonomy. You move from confirm every action to just do it and tell me if something goes wrong.
And for those who are really worried about the system breaking, I always recommend keeping your core automations, the stuff that must work, like smoke detectors, leak sensors, or basic security, in simple, hard-coded logic. Don't let the AI manage the fire alarm. Use the AI for the high-level, complex stuff that is a pain to code manually, but keep the life safety stuff simple and deterministic. That is the hybrid approach that gives you the best of both worlds.
That is just common sense. You don't want a hallucination to be the reason your alarm doesn't go off. But for things like, hey, I am feeling a bit tired, can you make the house more relaxing? That is where the AI shines. It can adjust the temperature, dim the lights, put on some lo-fi music, and maybe even start the dishwasher if it knows the noise won't bother you. It is handling the vibe of the house.
That is the ambient computing dream. The home isn't just a place where you live, it is a system that supports your life. And we are finally at the point where the hardware and the software are meeting. The January 2026 release was really the starting gun for this. We are seeing more and more MCP servers popping up for things like weather data, energy prices, and even local traffic. The agent can look at the traffic on the way to your office and suggest you leave 10 minutes early, then automatically start your car's climate control.
It occurs to me that we are also trading one kind of complexity for another. We are trading YAML complexity for prompt engineering complexity. Do you think this actually makes it easier for the average person? Or is it just a different kind of hobbyist rabbit hole for people like us?
That is a fair critique. Right now, in early 2026, it is still a bit of a rabbit hole, but the difference is the interface. It is much more natural to talk to an AI and refine its behavior through conversation than it is to hunt for a missing comma in a 300-line configuration file. The barrier to entry is shifting from technical syntax to logical intent. I think that makes it accessible to a much wider range of people. You don't need to be a coder to have a vision for your home.
I agree. It is the difference between being a coder and being a manager. Most people don't want to code their house, but they would love to manage it. They have a vision for how they want their life to feel, and the AI is the tool that translates that vision into reality. It is the universal adapter for human intent.
And we shouldn't overlook the social aspect of this. In a house like ours, where we have multiple people, me, you, Daniel, we all have different preferences. An agentic brain can learn those differences. It knows that when you are in the living room alone, the temperature should be 72, but when I am there, I prefer 68. It can negotiate those preferences in a way that a static automation never could.
It can be the mediator of the house. That might actually save some brotherly arguments over the thermostat, Herman. The AI can just say, I am setting it to 70, because both of you are in the room, and that is the optimal compromise for your historical comfort levels.
Right. It can see that I am in the room and you just left, so it can gradually shift the temperature toward my preference without me having to say a word. That is the true magic of ambient computing. It happens in the background without you even noticing. It is the invisible hand of the home.
So, looking forward, where does this go? If we are already here in early 2026, what does the smart home look like in 2028? Are we even going to have apps on our phones?
I think we move away from the dashboard entirely. The dashboard is a relic of the era when we had to manually control everything. It is a digital version of a wall of switches. In the future, the house just works. You might have a few physical switches for emergencies, but otherwise, the house is just responsive. It uses a combination of presence sensing, biometric data like your heart rate or skin temperature from a wearable and agentic AI to maintain the perfect environment. You won't control your home, you will just live in it.
It becomes almost like a living organism, a biological digital hybrid that you inhabit. It is a bit sci-fi, but when you look at how fast these local models are improving, it doesn't feel that far off. We are talking about 2 years, not 20.
It really doesn't. And the best part is that because we are doing this locally, because we are using things like Home Assistant and MCP, we are the ones in control. We are not renting our home's intelligence from a big tech company. We own the brain. We can upgrade it, we can change it, and we can turn it off whenever we want. That is the sovereignty we always preach.
That is the most important takeaway for me. Sovereignty. In an age where everything is a subscription and everything is in the cloud, having a truly smart home that lives on a piece of silicon in your own house is a radical act of independence. It is your data, your logic, and your comfort.
Well said, Korn. And if you're listening to this and you are feeling inspired to go rebuild your setup or try out a local Llama model, I would love to hear about it. We have a contact form on our website, myweirdprompts.com, where you can send us your success stories or your frustrations. We are all learning this together as the technology evolves.
Definitely. And hey, if you've been enjoying the show, a quick review on your podcast app or a rating on Spotify really helps us out. It is the best way to help other people find the show and join the conversation. We have been doing this for over 1,000 episodes now, and it is the community feedback that keeps us going.
It really is. We have come a long way since episode 1, and the technology just keeps getting more interesting. Thanks to Daniel for sending in this prompt, it gave us a lot to chew on. It is a reminder that even the most frustrating technical slogs can lead to something beautiful if you have the right tools.
It really did. I think I'm going to go see if I can prompt engineer our kitchen agent to stop turning the lights off while I am still eating my midnight snack. I think it thinks I am a ghost.
Good luck with that, Korn. I think the AI might just be telling you it is time for bed and that the snack is a bad idea for your sleep cycle.
Fair point. It might be too smart for its own good. Well, that is all for today. You can find all our past episodes and the RSS feed at myweirdprompts.com.
This has been My Weird Prompts. We will see you next time.
Take care, everyone. Stay curious and keep tinkering.
And keep those local models running. Goodbye.
Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the flows from sloth.